Okay, here we go. So real quick, stuff we had talked about. Click those closed. I want to see all phones. Anything that could distract you, please put those all the way away. We're starting fresh, new semester. We're going to get off to a good start here. So first thing I want to do is just review some of this. It's been a long time, right? We had those snow days after we covered this, and then we kind of focused on finishing up the other units in preparation for our final quiz. So this is some stuff that we haven't hit in a while, but see what you can remember. So the goal here is we want to convert a quadratic function from standard form, right, ax squared plus bx plus c form, into vertex form, which uses the a's and the h's and the k's, right? So we can do this algebraically. There were 5 steps. Remember what the first one was? It's been a while.
Y.
Say it again.
Make it to Y.
Set it equal to y. It's kind of a simple step. So the first one is we're just going to set it equal to y. If it's not already written that way, set it equal to y. You might be wondering why we do that. Well, the reason we do that is just so we have the left side of the equation to store stuff while we're working on the right side. We're going to do most of our work on the right side of the equation. Okay, what's next? What do we have to do to the right side?
Add 46.
Okay, we're adding 46 and then doing what? I guess what's our goal? On the right side of the equation, our goal is we want to get this thing into the form x squared plus bx. So what's that mean? We want to get rid of the constant, so we only have x squareds and x terms, right? And then we want the coefficient of x squared to be 1. So, Nancy, what's the first thing I got to do to put the right side into that form? No, I'm just going to ask, just kind of randomly ask people. So if I want to, I've got to only have an x squared and an x term. So what do you think? What's the first thing I need to do, probably? I got to get rid of that, right? How am I going to get rid of that one?
By adding 46.
Add 46. There we go. So the first thing is let's get rid of the 46. Add 46 to both sides. Okay, what do you think? What's next? What's next? Autumn, what do you think?
Divide everything by negative
Perfect. Divide everything by -2 because we need to have an x squared, not a -2x squared. So we'll divide both sides of the equation by -2. And what's that going to do? On the right side, when we divide the first term by -2, it gets rid of the -2. Positive 20x divided by -2 gives us -10x, right? And then on the other side, we'll just leave it. It looks complicated, but that's all right. We're just storing stuff over there anyway. Okay, so now steps 3 and 4 go together, right? Our goal is, the reason we're trying to get the right side to look like x squared plus some number times x is so that we can create a perfect square trinomial on this side, something that's going to factor using one magic number twice, okay? The way we do that is we're going to add just the right number to both sides to make that happen. Remember how we do that? So, okay, right, so we know that ultimately when we factor this thing, we got to find magic numbers that multiply to c and add to b, right? Well, b in this case is just -10, right? Everybody agree? If we're trying to create a perfect square trinomial, all we have to do is we have to add half of b squared. So b over 2 squared to both sides. So b over 2, if b is -10, b over 2 would be -5, right? -5 squared would just be 25. So we're just going to add 25 to both sides. We're adding half of b squared. So what's that going to give us on the right side? On the right side, we're going to get x squared minus 10x plus 25. On the left side, we're just going to add a, well, that's not supposed to be there. We're just adding 25 to what we already have. And it's still kind of a mess over there, but that's okay. We're just storing stuff. So what's this going to factor into? What are the magic numbers here that multiply to 25 and add to -10? -5 and -5, right? So it worked. It worked. If we have a perfect square trinomial, that means we're getting the same magic number twice, right? So we get -5 and -5. And so the right side is going to factor into x plus -5, or x minus 5 times x minus 5, right? Which is just x minus 5 squared. Now, we didn't have to really even think about that, though, because half of b is always gonna be the number that goes with x. That's always gonna be our magic number that we get twice, is half of b, every time. So we get x minus 5 squared on the right side. On the left side, we get a bunch of stuff, right? The important thing here is that that y is equal to the original function that we started with. So now our goal is we gotta get that y by itself. We gotta undo everything that we did to the left side to get the y by itself, right? Because the y, remember, is equal to our function. And all we're trying to do is write our function in a different form. So we gotta set it equal to y again. So what would the steps be now? Let's think about this in the context of order of operations. If we're gonna isolate something using order of operations, we just reverse the order of operations, right? So the first step is we have to add or subtract stuff that's by itself, right? It's not in parentheses or in the top of a fraction or something like that. So what's the first step going to be to get that y by itself? But what's the first thing? First I have to undo any loose addition or subtraction. Subtract 25. There you go. We're going to subtract 25 first. And that gives us that, right? Okay, so we got through that step. We check that one off. Now, is there any multiplication or division that we have to undo?
Multiply by 2.
Multiply by -2. I have to multiply both sides of the equation by -2, right? So on the left side, it's going to cancel the -2 on the bottom. I'm undoing dividing by -2. On the right side, I have to multiply the whole side by -2. So I have to distribute the -2 to both terms on the right. So I'm going to get -2 times the quantity x minus 5 squared. Now that's good though, right? Doesn't that look like a times x minus h squared, right? So we're getting there. And then -2 times -25 is plus 50. And then the very last step, subtract 46, and we're there. If I subtract 46, I got it. And now, what do you know? It's in the form I want it to be. It's in the form a times x minus h squared plus k, right? What's a? -2, and we knew that from the beginning, right? You can see that this is in standard form. A is -2. That part hasn't changed. What about h?
5.
What about k? 4. There we go. So we can do it by completing the square. The other thing we could do is, we could just skip completing the square, and we know that our goal is, this is in standard form, right? And we're trying to convert this into vertex form. It's in the form ax squared plus bx plus c, and our goal is to convert that into vertex form. Right? So all we really need to be able to do, well, we already know a is going to be the same the whole time, but I've just got to figure out what are the values of h and k that I could plug in for vertex form. I already know a. So there is a little trick. What are the values of a, b, and c in this function? It's in standard form. What are a, b, and c here? What's a?
A is -3.
What's b? And c is -8, right? But we don't really care about c. Okay? So a is -3 and b is -12. What's our formula for calculating h, which is just the x coordinate of the vertex? Close.
B over 2 squared.
No, well, I think I heard it.
-b over 2.
-b over 2a. Right, we've got the formula. H equals -b over 2a. I could plug that stuff in, couldn't I? If b is -12, -b is 12. 2 times a is 2 times -3, that's -6. So I just get -2, right? Yeah. So h equals -2, there's one number I can plug in. Right, that's one number I'm plugging in for, and I already know A is gonna be -3, so 2 out of 3 are done. I just need to find K, and plug those in and I'm done. How do I find K if I know H? Plug it in. K is the Y coordinate, so it's always what I get when I plug the X coordinate in, right? So that's gonna equal F of -2. If I plug -2 in for X, don't take a shortcut here. Make sure you're not skipping steps, because whenever we have an X, we're gonna replace it with a quantity, right? So that used to be an X squared, so now it's gonna be an empty quantity squared, where I can dump my number. Minus 12 times whatever my X value is, minus 8. My X value is -2. What's -2 squared? Times -3? -12 times -2. So what am I going to get here? 24 minus 12 is 12 minus 8. 12 minus 8? 4. So I can plug a 4 in there, and I get my answer, right? My answer is just f of x equals -3 times x minus -2, that makes that a +2 squared, plus k, which is 4. Right? Take a pick. You can convert standard form to Vertex form either way. What way do you like better? Probably this way? That's fine, you can do it this way. You can do it this way if you want. Okay, last step, last couple you're going to see. If we want to find the value of c that we would add to make a perfect square trinomial, what was our rule? It was what? Okay, now that's if I'm factoring, but if I'm trying to complete the square, if I've got x squared plus bx here, right, and I want to create a perfect square trinomial on the right side of the equation, probably, right? What number do I add to create a perfect square trinomial? Remember how we did that? Let's go back and look at our steps real quick. So we just added half of b squared, right? Half of b squared. So we got to figure out what that is. Half of b squared. Well, what's b in this case? B is -10/3. So what's half of b? Now, it might be easier, because I'm starting with a fraction, rather than dividing a fraction by something. Dividing by 2 is the same as multiplying by what? 1/2, right? Same as multiplying by 1/2. So we could just multiply 1/2 times -10/3, right? And then I could multiply straight across and get -10/6, or I could even reduce a little bit. -10/2 becomes -5/1. Either way, b/2 is just -5/3, right? But the number we're adding is b/2 squared. We want to square whatever we get for half of b. Well, what is -5/3 squared? How do I square a fraction? Easy. It's just multiplying it by itself, right? Just multiply straight across. So I'm just squaring the top and squaring the bottom. Right? What's -5 squared? What's 3 squared? There you go. Okay? That's all they're asking for those. And even if it's something complicated like a fraction, no big deal. You're just going to take half of whatever b is and then square it. Okay? This is saying essentially the same thing. Only this time they want us to skip down to the next step, and they want to know, what is this going to be if I write it, when I add c, whatever that is, on the right side, when I create my perfect square trinomial and I write it as a single factor squared, it's just x plus whatever the magic number is squared, right? Well, what is the magic number in this case? If we go back a little bit, the magic number that we ended up with down here is just b/2 every time, right? We add b/2 squared to the right side, so it factors into x plus b over 2 times itself, right? So what's our magic number going to be this time? There's b, right? Over 2. That's my magic number. I know that's complicated because it's a fraction, but you don't even have to think about it. That's the pattern that's always going to fit. Okay? All right. Let me turn you loose. Work on this stuff. You know the things you got to work on, and you know the order, right?